The sun. The most powerful force in our solar system. So huge that more than 1 million Earths would fit inside it. It generates the heat and light that sustains us. Without it, we wouldn't have life on Earth. But our sun is also violent and volatile, and becoming more dangerous as it ages. It will get hotter and thousands of times brighter. Evaporate away our oceans, melt the surface of our planet, and make any life on Earth impossible. Sunrise, a daily celestial wonder, bringing the heat and light that keeps us alive. We bask in its rays, and yet most of the time, we take the sun for granted. We think it's always been there, and expect it always will be. Our only worry is sunburn. But the truth is very different. The sun can wipe out our most advanced technology, be as powerful as nuclear explosions, and can put our lives at risk. And in the future, as the sun ages, its glorious energy will become a nightmare, driving humans off the face of the planet, potentially threatening our very survival as a species. Understanding what will happen to the sun is something that astronomer Don Brownlee knows about.
The sun lasts a very long time, but it doesn't last forever. All stars have a limited lifetime, just like all people have a limited lifetime.
Our lives on this planet are inextricably linked with the sun's life cycle. But how do we know about the sun's life, when it was born, and when it will die, especially when scientists are dealing with time spans of billions of years?
No forester ever watches a redwood tree grow for 3,000 or 4,000 years, and yet we absolutely know the trees start as little seedlings, they get bigger, they get giant, and eventually they die. Likewise, see millions of stars in the sky, and you're actually looking at stars in all the stages of evolution.
The sun is a star, just like those that fill the nighttime sky. So looking at other stars reveals fascinating details about our own sun's life. This is a stellar nursery around Orion's belt. Young stars less than 1 million years old are forming here right now, just as our sun did billions of years ago. This sundial represents the life of our sun, traveling from the distant past, starting with the sun's birth at dawn, 6 a.m., through till its death at dusk, 6 p.m. Right now, it is exactly 6 in the morning. The sun is being born. The sun is forming within what scientists call a molecular cloud, the dust and gas debris from hundreds of exploding stars. The molecular cloud is mainly made up of hydrogen, the most common element in the universe. Gravity draws the atoms together, so that over the course of 1 million years, the cloud collapses in on itself. Gradually, more and more material clumps together at the center. It's a bit like when fire dancers make circles. The further away the fire is from their hands, the slower it rotates. If the dancer nearest the camera makes a tighter circle by bringing the fire to the center near her hands, it rotates faster and faster. And it's the same in the molecular cloud. Molecules rotate more quickly in the middle, which becomes denser and denser, until the atoms in the center become so packed, so compressed, they heat up.
As I put compressed air into this model sun, I can feel it heat up, like hydrogen compressing when the sun was forming. And this is how the sun got hot and began the fires that warmed the Earth for billions and billions of years.
The temperature of the cloud soars to millions of degrees, so hot that the hydrogen atoms slam into each other and fuse. Huge explosions of energy are released. The force of these explosions pushes outwards against the force of gravity. Throughout its life, the sun will be in an endless tug of war between these two forces. But now, there's a stalemate. The pressures balance each other. The sun is born. The sun crushes together more than 99% of the original molecular cloud. The little bit that's left then forms the Earth and the other planets in a disk around the sun. Scientists generally agree on this model of how the sun was born. But theory is just theory. The sun is 93 million miles away, which makes real physical evidence hard to come by, at least until now.
3, 2, 1.
August 2001. NASA launches its most ambitious mission to the sun so far, Genesis. At Houston's Johnson Space Center, bringing a piece of the sun back to Earth has been a 10-year dream for Eileen Stansbury.
The chemical composition of the sun is like a fingerprint of the original solar nebula, and being able to catch a piece of sun and bring it to Earth to analyze is exciting.
Stage level's still looking good, and we just went supersonic.
But how do you catch a piece of the sun? Even the outside halo, known as the corona, is up to 3 million degrees Fahrenheit, a temperature no space probe could survive. The answer is to steal a bit of the solar wind, a stream of particles blowing away from the sun at speeds up to 500 miles per second. But the Earth is shielded from the wind by an invisible magnetic force field, the magnetosphere. So until now, we haven't been able to get our hands on it. To get around that problem, the Genesis spacecraft travels deep into space, 1 million miles from Earth. Here, wafer-thin strips of gold, sapphire, silicon, and aluminum, among the purest and most durable materials on Earth, are left to sunbathe in the solar wind. It's a little like dropping marbles into a children's ball pool. Scientists hope as particles in the wind hit the wafers, they will force their way deep inside the layers of molecules within the gold and other materials.
And those marbles will embed themselves within the gaps in the balls. And that's how the solar wind embeds itself within these pure materials.
Meanwhile, down on Earth, the success of a daredevil plan to catch the returning capsule in midair rests on a Hollywood stunt pilot. Fresh off the movie Mission Impossible 3, Cliff Fleming has his own impossible mission to complete. Fleming's task is to hover at an altitude of 10,000 feet, waiting for the capsule to parachute out of the sky.
This pole here was attached to the helicopter. It's about 20 feet long.
Then, Fleming will swoop down 8 feet over the parafoil and grab the 420-pound payload in mid-flight before lowering it safely to the ground. In 5 years of training, Cliff Fleming has a 100% success rate, catching a dummy capsule 11 times in 11 attempts. But these were just rehearsals.
In Hollywood, our film we work on, there's take after take. In this case, there's only one chance.
And having spent over $200 million on the Genesis mission, that one chance to catch the real capsule will be crucial. September 8th, 2004. 3 years after its launch, Having collected atoms from the sun for 884 days, the Genesis capsule begins its journey home. It's the culmination of years of planning and training to ensure that its valuable cargo arrives safely and provides scientists with the purest pieces of the sun ever to be studied on Earth.
We were anxious.
You had the adrenaline flowing that morning.
I've been working on this mission for a decade.
The capsule re-enters the Earth